It is late August of 1989, and the afternoon heat sits heavy over a quiet residential street in Tustin, California. Nick Nissen, an entomologist for the Orange County Agricultural Commissioner, stands on a manicured lawn with his head tilted back, staring up into the canopy of a mature ash tree. What he sees does not belong in a heat wave. It looks like a blizzard. The air around the branches is thick with a fine white powder that settles on his arms, drifts into his eyes, and clings to his shirt. He steps closer, and the powder moves. It moves under its own power because it is not powder at all. It is alive. Billions of insects, each one no larger than a pinhead, swarm across the leaves and turn the deep green canopy a sickly, mottled gray. Down the block, the parked cars wear a slick black film. The porches are empty because no one can stand outside. And Nick Nissen is looking at a creature smaller than a grain of sand that has brought one of the most manicured suburban landscapes in the United States to a complete standstill. The question that will follow him for the next 3 years is simple. How do you stop something this small when there are this many of it? The insect was the ash whitefly, and it defied nearly every tool modern pest control could throw at it. Within months of its arrival, it was draining the life from dozens of species of trees across California. Ornamental ash, flowering pear, pomegranate, and more. The expected response to an invasion on this scale is almost a ritual. Chemical sprays, emergency budgets, quarantine zones. And for several years, California followed that ritual exactly, pouring money into suppression with the best chemistry available. It did not work. And then, just a few years later, the crisis did not so much get solved as simply disappear. It was not beaten by a new pesticide. It was not beaten by more funding. It was not beaten by cutting down a single tree. It was beaten completely and permanently, for free, by an organism even smaller than the pest it destroyed, working without a budget, without instruction, and without anyone's permission. The way this ended is stranger and far more elegant than the war that was waged to stop it. To understand how a tiny fly conquered California and how something even smaller conquered the fly, you have to go back to 1988. That summer, agricultural inspectors in Los Angeles County began noticing something strange on the undersides of leaves. By the autumn, the sightings were formally confirmed, and the insect had a name: Siphoninus filii, the ash whitefly. Its native range runs across Europe, the Middle East, and North Africa, where it had lived for thousands of years as a forgettable background character. Just another insect in a crowded ecosystem that kept it in check. But in California, it landed in an empty room. No native predator recognized it as food. No specialized parasite had followed it across the ocean. What it found instead was a banquet: ornamental ash and pear and commercial pomegranate, planted close together across thousands of square miles of suburb and farmland. A single female could produce hundreds of offspring. In California's warm climate, the life cycle accelerated, generations stacking on generation, and by 1989 and 1990, the whitefly had pushed over the mountains and north into the Central Valley. A regional nuisance had become a statewide emergency, and it had happened in a single season. The first response was brute force. People wanted the swarms gone, and they reached for the only weapons they understood. Homeowners drenched their yards in commercial insecticide. They saturated the soil. They hired companies to inject chemicals straight into the trunks of their shade trees. Others simply blasted the leaves every morning with high-pressure hoses, trying to wash a living cloud off a tree. The stakes were not only aesthetic. California's enormous nursery industry faced disruption as other states threatened to refuse shipments of California plants. Pomegranate yields fell, and the pressure to find an answer landed squarely on the University of California and the state's biological control program. No pesticide spray solved it, no trunk injection solved it, no high-pressure hose solved it. The chemicals bought a few days of relief, and then a new generation hatched from eggs the spray had never touched, and the cloud returned. Worse, the broad-spectrum poisons were killing the ladybugs, the lacewings, and the predatory mites, the very insects that might have offered some natural resistance. The trunk injections were temporary at best and harmful to the trees at worst. By the turn of the decade, the verdict was clear. Humanity's chemical arsenal was useless against an enemy this small and this numerous, and California was staring down a permanent management bill that threatened to stretch into the hundreds of millions. For a while, the story everyone told was a story of doom, a permanent tax on California's urban forest, an endless cycle of spraying with no end in sight. The conventional wisdom held that once an invader spreads this far, true control is a fantasy. But that bleak outlook rested on an old understanding of how ecosystems behave. In 1995, researchers Steve Dreistadt and Monsieur Louise Flint published a study in the journal Environmental Entomology that quietly demolished it. They documented a collapse. In 1991, at their Northern California sites, about 98% of ash leaves were infested, trees defoliated, blackened with mold, dying. 1 year later, in 1992, that number had fallen below 1%. Densities dropped by 2 to 4 orders of magnitude. The whitefly was not eradicated. It was simply reduced to irrelevance. And the thing that did it was not a chemical breakthrough. It was a wasp. To see how a collapse that fast was even possible, you have to look closely at the machinery of the whitefly itself. The adult is tiny, barely a millimeter long, its pale body dusted in the white waxy powder that gives the swarm its snowfall look. Its life begins as an egg on the underside of a leaf, and in the warmth of a California summer, it can complete an entire generation in under a month. That speed is the whole problem. Generations overlap, populations compound, and the numbers run away. After hatching, the young pass through 4 stages. Only the first can walk. It crawls a short distance, finds a vein, sinks in its mouthparts, and never moves again. The rest of its life is spent anchored to the leaf like a translucent scale, doing one thing: drinking. And here is where a feeding insect becomes a neighborhood disaster. Each nymph pumps enormous volumes of sap through its body, taking the nutrients and excreting the excess sugar as a sticky rain called honeydew. That honeydew falls from the canopy onto leaves, sidewalks, cars, and patio furniture. Then a fungus called sooty mold colonizes the sugar and turns every coated surface black. The mold blocks sunlight, so the tree can no longer photosynthesize. The feeding drains its nutrients. The leaves drop early, the fruit fails, and the tree begins to die. And because the whitefly will feed on at least 55 different plant species in California, it had nowhere it couldn't go. When winter stripped the ash and pear of their leaves, it simply moved to evergreens like the native toyon, waited out the cold, and returned in spring. It was, in every sense, built to survive. The answer did not come from a laboratory bench. It came from the ancient, balanced ecosystems where the whitefly had always been ordinary. Recognizing that chemical warfare had failed, scientists turned to classical biological control, importing a pest's natural enemies from its homeland. Entomologists traveled to Europe and the Middle East, to Italy and Israel, hunting for the creatures that kept this whitefly quiet for millennia. They came back with 2. Both were put through rigorous quarantine to be certain they would not turn on native wildlife, then mass-reared and released across California in the early 1990s, quietly, with no announcement, no fanfare. What followed was a 2-species pincer. The first was Clitostithys arcuatus, a tiny lady beetle that hunts whiteflies for a living. Both its adults and its larvae devoured eggs and nymphs, pressing down on the surging population. But the beetle was the supporting act. The real force was smaller still, a parasitoid wasp named Encarsia inaron. The female Encarsia inaron is about 0.6 of a millimeter long, smaller than the pest she hunts. She lives roughly 3 weeks, and in that time she lays around 160 eggs. She works with surgical patients. She seeks out the 2nd, 3rd, and 4th stages of the whitefly nymph on the underside of a leaf, and with a needle-like ovipositor she pierces the nymph and lays a single egg inside its living body. She also feeds directly, puncturing other nymphs to drink their fluids, which kills them outright. When her egg hatches inside the host, the larva eats the whitefly from the inside, keeping it alive just long enough to finish growing. The nymph hardens, darkens, and turns a glassy brown. In the field, these are called mummies, and they make the wasp's work visible to the naked eye. Then a new adult chews a perfectly round hole through the back of the corpse, climbs out into the sun, and goes looking for the next host. The reason this wasp succeeded where engineering failed comes down to timing. The beetle needed dense crowds of prey to sustain itself. The wasp did not. It could track down even small, scattered pockets of whitefly, and crucially, it could survive the same host-free winter its prey did. When the whiteflies retreated to evergreen toyon to wait out the cold, the wasps went with them. When spring returned and the whiteflies came back to the ash trees, the wasps were already there, waiting to parasitize the very first generation of the year. That year-round pressure is what mattered. The whitefly could never again build the explosive spring populations that had darkened the skies of 1989. Within 1 to 2 years of release, parasitism of the nymphs across study sites ran extraordinarily high, and the invasion was over, suppressed to levels that vigorous monitoring could barely detect. Then come the economics, and they are almost unfairly clean. Before the wasp, the ash whitefly was generating millions in damage and threatening to shut California's nurseries out of other states' markets. Afterward, University of California researchers ran the numbers on what the intervention saved. The preserved aesthetic value of California's urban shade trees came to roughly $220 million at wholesale replacement value and nearly $300 million at retail. The entire program, foreign exploration, quarantine, mass rearing, release, and monitoring, cost about $1.25 million. Set the benefit against that cost, and the return runs into the hundreds of dollars saved for every single dollar spent. And it keeps paying. By replacing a permanent regime of spraying and tree removal, the program is estimated to avoid on the order of $200 million a year, every year, indefinitely. It remains one of the most cost-effective environmental interventions ever documented, a near-free biological program that turned a massive economic threat into a self-sustaining victory. The ash whitefly is not a one-off. It is a pattern, repeated wherever humans carry a species across a barrier it could never have crossed alone. Strip an organism of the enemies that once contained it, and it runs riot, and no amount of chemistry reliably puts that genie back. California had already lived this once, when the imported Vidalia beetle saved the state's citrus industry from the cottony cushion scale a century earlier. But the same power carries a warning, because intervention done carelessly can be worse than the disease. When Australia released the cane toad to control beetles in its sugarcane, the toads ignored the beetles entirely and went on to poison native wildlife across a continent. The difference between a triumph and a catastrophe is patience, humility, and study, understanding the web of relationships that already exists, and finding the single small lever that tips it back toward balance instead of swinging a hammer. It is late evening now in Tustin, and the sun has dropped below the roof lines, throwing long shadows across the street. Nick Nisson stands on the same sidewalk, looking up into the same ash tree. The air is clear. There is no white dust in the sky, no black film on the cars, no phones ringing off the hook downtown. A light breeze moves through leaves that are green and healthy and clean. He turns over a single leaf and finds only a few scattered mummies, each with the small round exit hole of a wasp that flew off long ago. The tree is quiet, and the peace it holds was never built on eradication. It was built on a balance, invisible, permanent, and free. We tend to look for loud, expensive answers to the problems we create. But sometimes the most powerful force in the landscape is a creature less than a millimeter long, working in silence on the underside of a leaf, asking no one's permission. So the question worth sitting with is this: given a success this complete, should we lean harder on biological control to solve the crises we keep manufacturing? Or does the risk of losing one more species on the world still outweigh the reward?